Alright guys, so we have covered a number of different ways of solving quadratics at this point. In Unit 5, we talked about how to solve by factoring. We've talked about how to solve by square roots. We've talked about how to solve by completing the square. But all three of those methods require certain things of you. Factoring requires the trinomial to be factorable. Solving by square roots requires you to be able to put it in some form of perfect square so that you can take the square root of each side. Completing the square, you got to have a good way of getting that a in front, and we've learned that not every trinomial is conducive to that. You end up with ugly decimals and fractions that you have to deal with. So we do have one last method to teach you. It's called the quadratic formula. So let's go ahead and get into the quadratic formula. Our learning target today is that we can solve quadratics using the quadratic formula. So in this method, before you get started, you have to have your quadratic written in standard form. Now remember, standard form of a quadratic looks like this: ax squared plus bx plus c equals 0. And really, I should have put one of these little formula sheet emblems there as well, because this is on your formula sheet. So you don't have to have that memorized, although you probably do by default at this point. So what you're going to do is you are going to take a quadratic. You're going to make sure it's in standard form, and then you're going to have a number here in front of your x squared. It may be 1, it may be something else. It doesn't really matter for this method, so that's nice. You're going to have a b, some value in front of your x, and you're going to have a c. And all you are doing is putting these values into a formula. That's it. It's just a formula. So let's get these notes really quick. Like I said before, the first thing you're going to do is write your equation in standard form. Then you're going to determine the value for a, b, and c. And then you're going to plug these numbers into your quadratic formula and then use your order of operations to simplify. So let's go ahead and do an example. In this first example, I've already got it set in standard form. I've already got all three of my terms on one side, and it's set equal to 0. Standard form, sometimes you'll see that it's set equal to 0, sometimes it's set equal to y or f of x. If it's set equal to y or f of x, just remember that when we're solving quadratics, what we're really looking for are those x-intercepts. And x-intercepts happen when your y is 0. So if I gave you a problem that looked just like this, but I had a y here, you would just set it equal to 0, just like we did when we were factoring and not completing the square, but when we were factoring and solving by square roots. All right, so I'm going to determine the value for a, b, and c. A, in this case, a is always going to be the value that's in front of x squared. If you don't have one, you guys all know that means you haven't understood 1. Your b is always going to be the value that's in front of your x. Make sure you pull the sign in front as always. It's going to be important as always. So it's going to be -9, and then c is always going to be your constant. I always liked the fact that c was constant because, you know, c for constant. So I've got -14. All right, now I'm going to plug these into my quadratic formula. So the quadratic formula is -b plus or minus square root of b squared minus 4ac, 4 times a times c, all over 2 times a. Every single time you hear me say the quadratic formula, I'm going to say all over 2a. A common mistake is that people put that fraction just under the -b or just over the b squared minus 4ac. You got to make sure it goes all the way across. When I was in school, we had a little song to help us remember. It was to the tune of Row, Row, Row Your Boat. If that's a helpful thing for you, then maybe go to YouTube and learn it, because I'm not going to sing it for you here. Okay, so when I plug this in, make sure that negative stays in front because that is a part of the formula. And when I plug in my b, I'm plugging in -9. So I end up with 2 negatives fairly frequently, so be prepared for that. And then plus or minus the square root of b squared. Put that in parentheses because you're probably going to use your calculator for this, and that's fine, but you've got to make sure that you put this in parentheses. Otherwise, the calculator is going to tell you that -9 squared is -81, and you're going to get the wrong answer. And then I have minus 4 times a, which was 1, times c, which was negative 14. All my 4's look like 9's when I write with this pen. I apologize. Negative 4. Negative 4. And 14. There you go. All over 2 times a, which was 1. All right, now I am running out of space a little bit. Oh no, I got room. Okay, so now I'm going to go through and simplify. The way I do the quadratic formula is first I plug everything in. Then I go through and I just sort of clean it up. We've got to follow our order of operations, which means we would need to do parentheses. I'm just going to write it over here so we've got it to reference. Now, the only parentheses that I can see are those ones I use to keep my negatives safe and to show me that I was multiplying. So I don't really have parentheses, but remember parentheses really means any grouping symbol. Well, this square root kind of serves as a grouping symbol. I have to do whatever's underneath that before I can actually take the square root of it. So I will need to take care of that. But within there, I've got some multiplication and some exponents. So what I usually do is on the first round, I go through and if I've got two negatives here, then negative times negative 9 gives me positive 9. And then plus or minus, I go ahead and take care of that exponent. Negative 9 squared is positive 81. And then I can go ahead and do this multiplication. What I do when I multiply this, I treat this like it's a negative 4. And in my calculator, I put negative 4 times 1, which obviously I don't need to do, times negative 14. So I put, can you see it? Yeah, I put that, and I hit enter, and I get positive 56. If I get positive 56, then what I'm going to write down is plus 56. If I had gotten negative 56, I would have written down negative 56. So I treat that minus sign like it's a negative, and then I write down whatever I get. If that confuses you, then you can treat it like it's a minus sign, and you would have to do positive 4 times 1 times negative 14, you get negative 56, and then you'd have minus a negative 56. I prefer to just treat it like it's a negative, but it's whatever works for you. And then don't forget about my 2a. On the bottom, I have, or sorry, in the denominator, I have 2 times 1, which is 2. All right. Now, once I've done all the multiplication and all the exponents, then I go ahead and add what's under that radical, because I can do that. So 81 plus 56 is 137. So now I have 9 plus or minus the square root of 137 over, all over 2. Now, at this point, I'm going to go ahead and check my square root, make sure that I don't have anything that can be simplified, or who knows, maybe 137 is a square root. I don't think it is. But no, when I put that in, it tells me the square root of 137 is just square root of 137, which means this is in simplest form. There's nothing else I can do here. 9 is not divisible by 2, and that's already in simplest form, so I can put it like this. That is my two solutions, 9 plus the square root of 137 over 2, 9 minus the square root of 137 over 2. If this were a word problem and I needed to have decimal answers, then I could put that in the calculator. I'd have to put it in as two separate answers, 9 plus the square root of 137 over 2, and then 9 minus. So I would have to do that two separate times. If you need help putting that in the calculator, just ask us and we'll show you. All right, I've talked a long time, so let's go ahead and get to example 2. Example 2 is very similar, except this time it's not in standard form. So I've got to put it in standard form, which just means move everything over to one side. So in this case, that's going to mean adding 4 to both sides. So then I've got negative x squared plus 3x plus 4 equals 0. My a value is right here in front of x squared, which is negative 1. My b value is right here in front of x, so that's a positive 3. And my c value is positive 4. When I plug this into the quadratic formula, remember I've got negative b plus or minus square root of b squared minus 4, look, my 4's are doing much better, times a times c over 2 times a. Negative b, my b is 3, so I'm going to say negative 3 plus or minus the square root of 3 squared. You can still put that in parentheses if you want, just to make a good habit, but it's not necessary when there's not a negative. So 3 squared minus 4 times a, which is negative 1, times c, which is 4. Oh, ugly 4 again. All over 2 times a, which means 2 times negative 1. So remember, every a that I have is going here and here. That goes in 2 spots. I don't know why I'm flashing like that. Every b that I get goes in 2 spots. It goes right here and it goes right here. C, he's sad and not quite as special. He's still special. C just gets to go in 1 spot. He just gets multiplied right there. So that C, that 4, shows up right here. That B, I put 3 here and here. And then A, I put in 2 spots as well, here and here. So you should see those show up, and it'll be like that every single time because it's a formula. All right, so now I get to go through and actually calculate what my answers are. There's no simplification that needs to happen here, so it's still just negative 3. Plus or minus 3 squared is 9. Minus 4 times negative 1 times 4. Negative 4 times negative 1 is positive 4, times 4 is positive 16. So I'm going to put plus 16, and then 2 times negative 1 is negative 2. All right, then square root of 9 plus 16, I can go ahead and do that addition because I'm still trying to work inside of that grouping symbol of the radical. 9 plus 16 is 25. So I have negative 3 plus or minus the square root of 25 over negative 2. Now, in the other one, we got to stop there because the square root of 137 is irrational, so we just left it in its simplest form. In this example, though, the square root of 25, hopefully you guys are all screaming at me right now that that is 5, plus or minus 5, because it could be 5 times 5, or negative 5 times negative 5 would also get you 25. So I have this, and when you can actually simplify that square root, then you have to go a bit farther. You're going to split this into 2 separate problems. One that's negative 3 plus 5 over negative 2, and one that's negative 3 minus 5 over negative 2. Hopefully you've learned by now that you can't just figure out what negative 3 plus 5 is and then use the positive and negative version of that. It doesn't work that way. So negative 3 plus 5 is 2 over negative 2 equals negative 1. Over here, negative 3 minus 5 is negative 8 over negative 2 equals positive 4. So my x values, my answers here are x can equal negative 1 and 4. And that is what I am boxing in as my answer. Now, hopefully you guys realize that if you get a nice pretty answer like this, that probably means that this could have been factored and we could have solved it that way. But, you know, sometimes, I'm not going to lie, I get lazy. I just use the quadratic formula on everything because it works really well. Unless I look at something and immediately say, oh, I know what the factors of that are. I can factor that. Or unless it's already set up to be solved by square root, quadratic formula will work every single time. It'll even show you when there are no solutions, and I'll show you that in the next video. But for now, you guys go ahead and try a couple of examples, and I'll see you back in just a minute.